Alright, this is a lesson about basic circle vocabulary. Radius, chord, diameter, secant, tangent, and a couple other things. So, first, a quick review of basic circle vocabulary. Alright, first of all, the definition of a circle is the set of all points in a plane that are equally distant from a point called the center. A radius is a segment whose endpoints are the center and any point on the circle. So a radius is like this, from the center out to the circle. A chord is a segment whose endpoints are on the circle. So this is a chord because it starts on the circle and ends on the circle. Technically this is a chord as well, but it's a special chord that goes through the center. So a chord is a segment whose endpoints I already said that. A diameter is a chord that contains the center of the circle. So it's a chord through the center. A secant is a line, not a segment, but a line that intersects the circle at 2 points. Okay? So look at a chord and look at a secant. Almost the same. What's the difference? A chord begins and ends on the circle. A secant is just passing through. It goes forever in both directions because it is a line. Okay, vocabulary, you just have to memorize it. So practice it, memorize it. Alright, a tangent is a line that intersects the circle at only one point, called the point of tangency. You can have a common tangent if you have two circles, if you have a line that touches each circle only once. This would be a common internal tangent because it passes between the circles. This is called a common external tangent because it does not go between the circles. It just is tangent outside of the circles. Alright, so there's your basic vocabulary. Now let's see if we can apply that to this lesson here. So number one, tell whether the line, ray, or segment is best described as a radius, chord, diameter, secant, or tangent of circle C. By the way, that means circle C. So segment DF. I better zoom in. Segment DF is right here, alright, because here's D and here's F, so here is segment DF. Alright, which vocabulary word is that? That is a chord. Okay, segment DF is a chord. Okay, what about segment AB? Let's take a look at that. Okay, segment AB. Well, there's A, there's B, here's segment AB. Alright, segment AB is a tangent. You can tell by the way it intersects the circle at only one point. So, segment AB is a tangent. What about segment CE? Okay, segment CE. There's C, here's E, here's segment CE. Well, that is a radius. A radius goes from the center of the circle out to a point on the circle. So CE is a radius. What about segment DE? Okay, so here's D, here's E, here's segment DE. That is a chord, but it's not just any chord. It's a chord through the center of the circle. And a chord through the center is called the diameter, or a diameter. Okay, line AG. Alright, here's A, here's G, and this whole thing is line AG. Well, a line that cuts through the circle like that is called a secant. Line AG is a secant. And ray EB. See the little symbol, ray EB. Okay, here is ray EB. Ray EB is once again a tangent because of the way it only intersects the circle at the one point. And even if it did keep going, it still would only touch at one point. So this is definitely a tangent, and point E here would be the point of tangency. Okay, that was number 1. Okay, read along with me number 2 as I slide across the page. Number 2 says, draw a circle P. Draw a tangent ray on the circle and label it ray CD. Okay, so I need to draw a circle B. Okay. So here's a circle. The thing that makes it circle P is if I put a if I call the center P, then that makes it circle P. Alright, now I am supposed to draw something else, but I already forgot. A tangent ray on the circle and label it ray CD. Alright, if it's going to be a tangent ray, it needs to touch the circle at only one point. And I don't mean like this. Okay, I mean this would be a ray. But this would not be a tangent ray, because if you continued it, it would go inside the circle. So you need to start with a line of tangency, something like this. Okay, start with a line of tangency. Okay, and then upon that line, you can begin to draw your ray, your tangent ray. Okay, so I'm going to make this dotted because it's just a guide. I'm going to erase it when I'm done. Okay, so this is clearly a tangent line. Now here I come with my tangent ray. So this would be the point of tangency, and you know, I could have a ray going like this. Okay, so that would be a tangent ray, and it's supposed to be ray, I believe it was CD, and when they say CD like that, C is the end point, and then it goes through D. Okay, so this would have to be C, and I'd need a point D for it to pass through. So that makes this ray CD. Okay, now I can get rid of my guidelines over here, and that's how you do that. Now, read with me number 3 as I slide along. Draw a circle P, draw a secant on the circle, and label it line EF. Okay, so circle P with a secant EF. Okay, so here is another circle P. Alright, it's circle P as soon as I make the center be P. And here comes a secant. Alright, a line cutting through like that is a secant, and it's supposed to be secant EF. So since I've already sort of got 2 points happening here, I might as well use these. So if I call this E and F, then there I've got secant EF. Alright, how about number 4? Draw circle P, and then draw a chord on the circle and label it segment GH. Okay, so one more circle P, and okay, so circle P. Alright, that makes the circle P. This time I'm supposed to draw a chord, so it should begin and end on the circle. So there's a chord, and it's supposed to be segment GH. So I'll just make this G and this H. So segment GH. Okay, there you go. State the best term for the given figure in the diagram. Wow, that looks very complicated. Alright, point F. Okay, let's look and find point F. Alright, it's not the center. Point F is right here. Now you see this is a tangent line, so point F would be a point of tangency. So point of tangency. Okay, number 6, line FE. Okay, so here's F, here's E. So line FE is this line right here. Okay, that's line FE. Okay, now let's be real specific. This line is a tangent line. Alright, it has a point of tangency on each circle. Alright, E is a point of tangency, and F. Now, so it is a common tangent, since it's a tangent for two different circles. Now, is it a common internal tangent, or is it a common external tangent? This is a common internal tangent because it passes between the two circles. Okay, so common internal tangent. Okay, how about segment HG? Okay, segment HG is right here. That is clearly a radius. Alright, from the center to the circle is called a radius. Alright, how about segment DB? Segment DB is right here. What do you call that thing? That is your typical chord. Beginning and ending on the circle, that is a chord. Alright, how about point C? Here's point C. That's the center of the circle. Okay, how about segment BE? Here's segment BE. What do we call that? That is a diameter. Alright, it's a chord, but it's going right through the center of the circle, so that's called a diameter. Okay, how about line DB? Here's line DB. Alright, passing through point D and point B and going forever. What do you call a line that just cuts through the circle like that? That is called a secant. Okay, what about line AG? Take a gander at line AG and tell me what you think I'm going to call that. It is a tangent, but because it's the tangent of both circles, it is a common tangent. Now, is it a common internal tangent or a common external tangent? This is a common external tangent because it passes outside of the two circles, not between like some other tangents. Okay, so line AG was a common external tangent. Alright, on number 13, we're supposed to use the diagram to determine if the statement is true or false. Okay, the distance between the centers of the circles is equal to the length of the diameter of each circle. Alright, so first of all, the distance between the centers. So let's look at that. Alright, so here's the distance between the centers right there. Alright, I can just count the squares. 1, 2, 3, 4. Alright, so the distance between the centers is 4. Okay, now what's this other distance they're talking about? Is equal to the length of the diameter of each circle. Okay, so yeah, let's talk about the diameter of each circle now. So here's the diameter of circle A, and here's the diameter of circle B. Oh, look at that, 4 and 4. So that's true. Alright, the distance between is the diameter of each circle. Alright, so we will classify that as true. Alright, number 14. The lines y equals 0 and y equals 4 represent all of the common tangents of the two circles. Lines y equals something are horizontal lines. Remember, like horizontal asymptotes? So y equals 0 and y equals 4. These are horizontal lines. Okay, so the line y equals 0 is this. This is the line y equals 0. And 1, 2, 3, 4. So this is the line y equals 4. So true or false, these are the only common tangents. False. There's another common tangent. It goes right here. Okay, this is, let's see, 1, 2, 3, 4, 5. So a vertical line, this is the line x equals 5. X equals 5 is also a common tangent because it's tangent to both circles. Okay, so I'm going to say false, and maybe I'll just add in x equals 5 is common internal tangent. Okay, number 15. The circles intersect at the point 6, 3. Let's see. I see the circles intersecting. They intersect right here. 1, 2, 3, 4, 5. 1, 2. So that's false because the circles intersect at the point 5, 2, not 6, 3. So false. Okay, and I'll just cross that out and put 5, 2, man. Alright, number 16. Suppose the two circles shown are inscribed in a rectangle. The perimeter of the rectangle is 36 units. Alright, inscribed in a rectangle means if I drew a rectangle around these, like touching the circles on the sides of the rectangle. Okay, so the rectangle in question would be this rectangle right here. Make it slightly smaller. And I guess I should make it see-through, shouldn't I? Shouldn't I? Alright, so this is the rectangle in question. I think they asked us about the perimeter, did they not? The perimeter of this rectangle, okay? So these circles are now inscribed in a rectangle. Now, the long side, the length of the rectangle, is 1, 2, 3, 4, 5, 6, 7, 8. Alright, which means this is 8 up here as well. Now, as we've discussed before, the width or height, whichever one you want to call it, is 4. Okay, so 8 plus 8 is 16, and then plus another 8 is 24. Alright, so the perimeter of this rectangle is 24. So that makes this false because they said 36. So this is false. It's 24 units. And that brings us to the end of this fine lesson. I hope this was helpful to you, my good people. I will see you on the next video. Later days.